Interpolation. We use linear interpolation to find a value between two values given on a table. If we go to the table and our value isn't actually there, but we see that our value is between two other values, we use linear interpolation to find our value. And the tables are set up so that the relationship between values on the table are linear, or that we're not losing enough or there, we don't lose anything by using a linear relationship between those two values. So I strongly encourage you to find a method and practice it repeatedly until you can do interpolations with ease. If you see two values, that you have a little algorithm of some sort that works for you. I'll show you the one that I use when I do linear interpolations. Essentially, all we're doing is setting up a simple ratio. And so, it's not really anything fancy, but it's the concept behind what we're doing and getting in the rhythm of it. So more than just blindly doing something, I just strongly suggest that you figure out, get an understanding of this, and then figure out a method that works for you. But let's say that we're given some values. We have values A and B, and C and D, and our value, we're given X, and we're looking for Y here, and we just know that they're between those two values, and that there's a linear relationship between these. So that's what we're doing here. And so we set up a little proportion, and then solve for the unknown. In this case, we're trying to find Y. We're saying that we're given all the other values. A and B and C and D we found on our table. Let's say A and C are pressure and B and D are temperature. So A and B were a pressure-temperature relationship on our table, and C and D were pressure-temperature relationship on our table. We're given X is some pressure and Y is the temperature that we're trying to find, or any myriad of other possibilities with that. But A, C, and X all have the same type or the same property. So all temperature, all pressure, all something like that. And value 2, same thing. They're all the same. All value 2 are the same. Anyway, we set up our proportion, and I'm taking the relationship between X and A and dividing it by finding a ratio of the relationship of C minus A. That's what we can see here. So this divided by this, and then that has to equal the same proportions of this to this. So again, we're taking and just setting up a proportion. This is to that, what that is to that. And then we're using that and rearranging to solve for our unknown Y. So just rearranging that, I end up with Y equals B plus the ratio of X minus A over C minus A multiplied by D minus B. Maybe I should make these a different color to really stand out here. And then I've just separated my variables and added the B to the other side. So anyway, you can just use this if you want. That's the thing you don't know, as long as you're consistent and you know what those values are. But if you practice it enough, then it just comes. You can just do it in your calculator and find out what it is. You will, I promise you, use this oftentimes going forward. So here's a little example. And we can use that same little algorithm to do this. So on table A3, I found the associated saturated temperature for a pressure of 1.014 bar. It's 100, it's 90, no, I'm looking for the temperature, I'm sorry, for a pressure of 1.014 bar. And on table A3, we note that a pressure of 1.014 is not on the table. We read the values above and below, and we're given that a P of 1 is a temperature of 99.63 degrees Celsius, and a pressure of 1.5 bar is associated with a saturated temperature of 111.4 degrees Celsius. And so we know that our temperature for 1.014 bar is somewhere between 99.63 and 111.4. So setting up my relationship here and then solving for the unknown here, T, gives me this equation, and I end up with approximately 100 degrees Celsius. We end up with 99.96 degrees Celsius, which is approximately 100 degrees Celsius. But that is what we're trying to do with linear interpolation.